Hi, and welcome to the Learn Electronics India channel. I am Meghna, and today we will be learning about the circuit theory basics. This includes the fundamental laws we need to be aware of before analyzing any circuit. Those laws include Ohm's law and Kirchhoff laws. Before moving, let us first understand the fundamental concepts in circuit theory. So a circuit is basically a pathway or it is a closed loop and it allows the current flow through that path. Any circuit comprises of the different electronic circuits that we studied. For example, resistor, capacitor, inductor, diodes, and some voltage source and current sources, etc. And in circuit theory, we will design a circuit, we will analyze that circuit, and we will troubleshoot that circuit for any errors and further fix those errors in the circuit. So in order to do all these things, we need to have a knowledge of the different components in electronics, the concept of current, resistance, voltage, and how we calculate power, energy, and the main laws, that is Ohm's law and Kirchhoff's laws. Now let us start off with Ohm's law. So Ohm's law is the relation between voltage, current, and resistance. And according to Ohm's law, the current is directly proportional to voltage. If we remove this proportionality constant, then we will introduce resistance in the equation. So if we frame that into a sentence, the current that flows through a conductor is directly proportional to the voltage across the points of that conductor, provided factors like temperature remain constant. Temperature will never remain constant, but still in real time we do use Ohm's law and it is assumed every time that temperature remains constant. So sometimes there might be some errors in real time that will be because of change in temperature. So I directly proportional to V is the original equation that defines Ohm's law, and to remove the constant we use R. If we reframe this, we can write it as V equals IR. So that is an easier way how we remember Ohm's law, but in sentence, this equation comes right. We can apply Ohm's law to both DC and AC circuits. So another way to frame this Ohm's law based on this equation would be the current flowing through a conductor is directly proportional to the voltage across the ends and inversely proportional to the resistance between them. We'll further see how we can use this in a circuit, but for now, let us go to Kirchhoff's laws. So Robert Kirchhoff, he's the one who found out Kirchhoff's laws. There are two different laws. One law talks about current and another law about voltage. And any circuit we can analyze using Kirchhoff's laws and Ohm's law. So let us first move to Kirchhoff's current law. Looking at the statement, it says that the algebraic sum of the currents meeting at any junction of an electric circuit is zero. So in this image, we can consider this point N as a junction, and there are 5 different currents flowing. Some are flowing towards the junction and some are flowing away from the junction. So summation of all these currents is zero. That is what KCL talks about. Kirchhoff's current law can be abbreviated to be KCL. Now from the figure, if we write it in the form of equation, we can consider currents flowing through the junction to be positive and currents flowing away from the junction to be negative. So here I1 is flowing towards N, I2 is also flowing towards N, and I4 is flowing towards N. So I1 plus I2 plus I4, these have positive signs, and I3 and I5 are flowing away from the junction, so they have a negative sign, and that we equate it to 0. So this first line or the first equation is formed based on this mathematical representation of KCL. Now, if we reframe this equation, then we can take I1, I2, I4 sums on one side and sum of I3 and I5 on the other side. Now, based on the second equation, we can reframe the KCL to understand in a better way. At any junction in a circuit, the sum of currents entering the junction is equal to sum of currents leaving the junction. You can do vice versa. You can take I1, I2, I4 to be negative I3, I5 to be positive, then also you will arrive at this equation. Next, let us understand Kirchhoff's voltage law, which is abbreviated as KVL. According to this, in any electrical circuit, the algebraic sum of all the EMFs and the resistive drops is equal to 0. Now, EMFs and resistive drop is two new words, but both of those means voltage. EMF is usually referred for sources. So it means electromotive force, which is an electric potential difference produced by a source, such as a battery. So in battery, instead of saying the voltage of the battery or the potential difference in the battery, we say it as EMF of the battery. Its unit is still volts, and it does the job of what voltage does. And resistive drop means it is the reduction in voltage across a resistor. So we have studied that resistor opposes the flow of current, and the current will remain same in the circuit, but whatever energy the battery supplies, some part of it will be consumed by the resistor and it will be transferred as heat energy. So when some amount of that voltage is being taken up by the resistor, it is natural that the voltage is reduced. Now that reduction in voltage, we call it as resistive drop. And V is equal to IR is what we studied in Ohm's law, and that is what we have written. So across resistor, we take the voltage drop, that is V equals IR, and E stands for EMF, which is also voltage. So summation of voltage of the sources and the resistive drop across the resistors is equal to 0. Before we move on to analyze a circuit, let us first understand some concept. So EAB and EDA are the direction of the voltages of this battery E. Now here, if we take EAB, it means we are tracing this voltage from A to B. So the battery is traced from the negative terminal to the positive terminal, which means it is a voltage rise. And hence the EMF will be positive. So EAB is positive. Whereas if we trace this battery from B to A, it means we are moving from the positive terminal to the negative terminal. This is voltage fall, and hence we take EBA to be negative. So voltage rise means from negative we are coming to positive. So the second terminal which we have, it is positive, which means it is voltage rise. Hence EAB is positive, and if you are moving in this direction, the second terminal which we come across is the negative terminal. So from positive, if it is moving to negative, it is voltage fall or voltage drop. Similarly, considering this resistor, it has a current I flowing through it. Now if we consider IRAB, again it moves from A to B and it is in direction of current. So this voltage drop IR of AB or VAB is along the direction of current, and that we consider as a voltage fall. Now voltage fall, again we represent it as negative. Whereas if we consider the other way around, that is IR of BA or VBA, it means we are moving from terminal B to terminal A. And our direction and the current's direction are opposing. So the direction of this voltage VBA is against the current direction, which means it is voltage rise, hence it is positive. So you can see Ohm's law coming into action here. VAB is taken as I into R. So that voltage drop across a resistor, instead of taking it as V, we take it as product of I and R. Now let us move on to analyze this circuit. First, we will apply KVL to this. So there are two loops. One is loop 1, another one is loop 2. So we will first apply KVL to loop 1 and then KVL to loop 2 based on whatever basics we learned in the previous slide. Now considering loop 1 means from A to B, then C, D, A, or D, A, B, C, D. So if we move in this direction, now we are moving from D to A and the voltage rise. It is from negative to positive. So this would be a positive voltage. So plus V, that is V. Now we will move from A to B. Here the current is I1 is moving in this direction and we are also moving in this direction, which means it is voltage drop. So that is what is written here. Current moves from positive to negative and we take the sign of the second terminal that we meet. So here we have negative sign, which means I and R would be negative here. So minus I1 R1, minus I1 R1. And if we move this way, we have current I2. Again, we are in the direction of current. We are moving from B to C and direction of current is also from B to C, which means it is again voltage drop and hence it will be I2 into R4. If we come from C to D, there is no component here. Hence, we will not be writing anything, which means we will equate it to 0. So, V minus I1 R1 minus I2 R2 is equal to 0. That is the first equation. Next, coming to loop 2, which means from C, we will move to B, then to E, then to F, and then back to C. Now in this case, we are moving from C to B and current is flowing from B to C, which means we are opposing the direction of current and it is voltage rise. So if you can see when we are moving like this, the second sign we meet at is the positive sign. So it will be plus I2 into R4. So plus I2 R4. Next, as we move from B to E, current I3 is coming down, which means I3 will be flowing here also. So I3 is also moving from B to E. We are also moving from B to E. So it will be minus I3 into R2. Then from E to F also, we are along the direction of current I3. Hence, minus I3 R3. There is no component here, so equate it to 0. So I2 R4 minus I3 R2 minus I3 R3 is equal to 0. So this is how we analyze a circuit. Some values would be given and we will have to substitute those values and find out whatever is asked in the question. We might be asked to find voltage or current depending on the question. Now next, let us apply KCL to this point B. So there are three currents here, I1, I2 and I3. If we consider point B, I1 is flowing towards B, I2 is flowing away from B and I3 is also flowing away from B, which means I1 will have a positive sign and I2, I3 will have negative sign. So I1 equals I2 plus I3 or I1 minus I2 minus I3 is equal to 0. So that was about KCL. So here we studied about Ohm's law, KCL and KVL. Even if you cannot remember the statements, these formulas or these equations would be enough to frame a statement out of it. And we saw how we could use KCL and KVL in a circuit and how Ohm's law was used in each of these analysis. After these three laws, we have superposition theorem, Norton's theorem, Thevenin's theorem. Those are some important theorems to analyze some complex circuits. But for simple electronics, these three laws would be enough. Stay tuned for further videos. Thank you.